Imagine you're an astronomer and you're sitting in your laboratory with your telescope, gazing at the universe, at distant stars and galaxies, when suddenly you notice a signal that shouldn't be there. Maybe you just imagined it. After all, you had been staring at graphs for hours, and sometimes that can lead you to hallucinate, right? But wait, there's the signal again and again and again, and every time it's from the same spot in the sky. What does this mean? Could it mean? Wait, let me back up a little bit. What I just told you was an actual day in the life of Jocelyn Bell Burnell in 1967. Back then, she was just a 24-year-old graduate student in Cambridge University. That means that she just finished her BSc in physics and now she was studying to get her PhD. Jocelyn was specializing in an area of astronomy called radio astronomy. That meant that she was observing objects in the universe that emitted radio waves. She came to Cambridge University when her advisor Tony Hewish invited her, and he had one job for her. Tony Hewish had designed on paper this telescope that could detect these distant objects called quasars. Quasars are considered one of the brightest objects in the universe. And Jocelyn and 4 of her teammates were tasked with actually building the thing. And this telescope isn't exactly like the ones you've probably seen. For one, it was giant. When I say giant, I mean giant because it covered an area of over 57 tennis courts, if you want to imagine that. So Jocelyn and her team actually did accomplish this and they built the telescope. After the telescope was built, the 4 of her teammates left the group. So Jocelyn was actually left alone to operate the giant telescope. Now this must have been pretty scary because Jocelyn was coming from a part of the United Kingdom that was not so big and fancy like Cambridge. And when she walked into the university, she was really intimidated. Everybody seemed super smart and intelligent and fancy and nothing like the people back home. And Jocelyn actually developed something that is called an imposter syndrome, a feeling where she felt that she is not good enough for this place and that they had made a mistake by admitting her. She was pretty convinced that it was only a matter of time before they found out that she wasn't good enough and they would kick her out. But she calls herself a fighter, and for that reason, she decided to do her best until they did find out. And Jocelyn actually did a pretty good job with the telescope. In the course of her years there, she discovered about 100 quasars. There's something I have to tell you about this telescope that she built. Like I said, it's nothing like the telescopes you and I have seen. And what you observe from these telescopes aren't images. You can't just look through this telescope and spot a quasar in the sky because quasars are far too distant from us and they don't emit light, they don't emit radiation that can be seen by human eyes. So the data that you get from these kind of telescopes look more like graphs. And you have to remember that it's the 1960s and there were no computers. So Jocelyn's job was to scan through lots and lots of papers, lots and lots of graphs to actually spot these small signals that she knew came from quasars. On a good day, she would probably scan through nearly 100 feet of paper. So it was on one such day when she was looking for quasars that she found this one signal that looked a bit odd. It looked something like a pulse where it would appear about 1 second apart. And Jocelyn wondered that what could be emitting this kind of signal and what did it all mean? Her first thought was, could it be some kind of a star or some undiscovered object that was releasing these radio waves? But when she showed it to her advisor, Tony Hewish, he was pretty convinced that this was definitely coming from something artificial. Perhaps it was coming from a machine in their own laboratory or nearby that was emitting radio waves, and Jocelyn's telescope was mistakenly detecting it. Or perhaps it was artificial but not made by humans. Maybe it was made by extraterrestrial life. They actually thought about this. In an article many years later, Jocelyn said this: We did not really believe that we had picked up signals from another civilization, but obviously the idea had crossed our minds, and we had no proof that it was an entirely natural radio emission. It is an interesting problem. If one thinks one may have detected life elsewhere in the universe, how does one announce the results responsibly? Who does one tell first? Jocelyn even later jokingly said that she was quite irritated. Why was it that of all the times it had to happen now, when she was already so frazzled, trying so hard to make this PhD work, trying so hard to make it in a place that she totally did not fit into? And why did these silly aliens choose this time to communicate with humans? There was another thing that Jocelyn was quite concerned about. If it did come to be that the signal was a sign that her telescope was malfunctioning, it meant that the years of work that she put in to build this telescope were not as fruitful as she thought. So the thought that something might be wrong with the telescope was quite upsetting. So the next few months, Jocelyn was determinedly checking about this rogue signal. Where was it coming? What did it mean? And over the next couple of months, she actually found out that she could detect such signals from different parts of the sky as well. That's when she became sure that this was coming from some previously undetected object in the universe. By November, other telescopes which are not Jocelyn's also started detecting these signals, and it was finally confirmed that a new type of object had been discovered, which would later come to be known as pulsars. Same year, Jocelyn and her advisor Tony Hewish published a paper where they described the discovery that they had just made. So what are pulsars exactly? Pulsars stand for pulsating radio sources. They are sort of like big balls of light. They are spherical, about the size of a city, but their mass is greater than that of the sun. And they also have these two opposite sources of light which keep rotating, sort of like a lighthouse. In the years that followed, pulsars became an incredibly useful tool for astronomers. It kept really precise time, so they could use it to measure these very delicate physical phenomena that they would not be able to measure otherwise. They were also useful for navigation and for discovering other types of objects like neutron stars. And most importantly, pulsars are still used to test some of the most fundamental theories in physics, like Einstein's relativity theory. When the news of the discovery of the first pulsar came out, naturally there was a lot of excitement among the astronomy community. And when the media found out that there was a woman involved in the discovery, there was an even more buzz of excitement. In fact, Jocelyn found herself interviewed by journalists, but she was quite put off when the questions she would be asked were not about pulsars and not about her research, but often questions like, what color is your hair? How tall are you? Do you have a boyfriend? Clearly, these journalists had no idea how to speak to a woman scientist. While this was quite annoying, Jocelyn decided to put up with it because she knew that the discovery of pulsars needed the publicity in order to be known to the rest of the world. Once the discovery of pulsars became confirmed, Jocelyn Bell Burnell went on from radio astronomy to gamma ray astronomy and other fields of research. About 7 years after the discovery was made, her advisor Tony Hewish and another scientist won the Nobel Prize in Physics for the discovery of pulsars. Now, this did generate quite a bit of controversy because many people felt it was unfair that Jocelyn Bell Burnell, who actually was responsible for observing the first pulsar, did not win the prize. But Jocelyn herself is quite unbothered by this. But in 2018, Jocelyn did win another really big prize. This one is called the Special Breakthrough Prize in Fundamental Physics, and Jocelyn won it. It came with a really handy cash prize of $3 million US. Guess what Jocelyn did with the $3 million? She donated the whole amount to women, minority, and refugee students who were seeking to become physics researchers. Now that, if you ask me, is an inspiring story. I hope you enjoyed this episode of Get to Know. And if you did, like always, I also have some extra links for you to read or watch or listen to if you want to know more about Jocelyn Bell Burnell. And I would highly recommend that you do listen to her talk, because not just is she amazing in explaining her field of research, she's also pretty funny, and that makes her really fun to listen to. So like always, don't forget to like, share, and definitely subscribe to our channel so that you can know when the next episode of Get to Know is out. See you later.